Next year, that's what you'll be doing.
Yay! Woo!
That looks
Oh my god.
It's easy.
It's
All right.
so easy.
In the meantime, all right, yeah, but I do want to say, guys, that is kind of dependent on your ERBs. All right. So this, yes, really. So now, listen, again, for today, I need you to really pay attention. All right. Again, this whole next month or 6 weeks, I'm really trying to focus on your ERBs and making sure that you do very well. Again, now, the problem is on the ERBs, they don't really give you the formulas and they just plug the numbers in the formula and that's the answer. You always have to think about it. They always kind of give you word problems. So we're going to concentrate on that. All right. Yesterday we did circumference. So today we're probably going to do what? Area. All right. Now, from last year was the first time you really learned area of a circle. Does you remember what the formula was? Area of a circle. Go.
It's like A equals R to the power of 2, 3.
Close. What?
The area is the pi times 3.
That's exactly correct. Area equals. Now listen, I always try to remind kids the reason why it's r squared is because when you measure area, you measure with what? Squares. So that's how I was able to know the difference between the area formula and the what? Circumference formula. If you notice circumference is one-dimensional, that means you're measuring a length, whereas in area, it's measuring 2 dimensions. All right? What?
What are the numbers?
All right, so let's not worry about that right this second. All right? Now, again, formula A equals pi r squared. Make sure you know that. Today it's the same routine. Every time you're going to write the formula, then you're going to put in the substitution, then you can use your calculator. Is everybody with me on that? All right, I'm not accepting anything else. That's the way it's got to be done. All right, because I'm trying to put the formula into your long-term memory. All right, so A equals pi r squared. At the top of the page, there you go. Numbers 1 through 26. We're doing numbers 1 through 26. And again, every single day, you need a pencil, paper, and calculator. That's what I need for you to have. All right? So here we go. Number 1, the first thing we're doing is we're writing the formula. A equals pi r squared. What is the radius?
7 meters.
7. So we have A equals pi times 7. Then you hit the square button. What does the square button look like? It looks like that. All right? That's the square button on your calculator. All right? After you hit the square button, you have to hit equals. So I would like someone to tell me the area is approximately, I'm waiting. What?
Mine went crazy.
Yeah, it's supposed to go crazy because it's a pi button.
153.9.
So we're rounding to 2 decimal places, and then we would say meters squared. It's about 153.94 meters squared. What?
Why wouldn't the I thought the exponent 2 was supposed to be inside the equals.
No, you're squaring 7. All right, you're squaring 7. Yes.
Why do the radius and not the diameter?
What's the formula?
Pi times radius.
So why are we not using the diameter? Because it's not in the formula. Agreed?
Yeah, I agree.
That's it. That's exactly right. Use the formula. All right? Use the formula. The area is not interchangeable. I understand what you were saying. All right? Circumference, you can do pi times d or 2 pi r. But not for area. They're not interchangeable. You have to have the radius. What?
It wouldn't work when I tried to do that.
It always works. You just may not know how to use your calculator.
Oh, is it this one?
The x squared.
Ooh. I was touching the wrong button. No, not mine.
All right, number 2. Here we go. We're going to write down the formula. What is it?
A equals pi
Good.
So A equals 5.
What's the radius?
Oh, times 2
That is correct.
squared, which is about 12.57.
1.57. All right, is everybody okay with that? Any issues?
Squared.
Brian, does anybody have any issues? All right, what?
So, like, the measurement always is the foot square.
Yeah. All right. Chloe, number 3.
So,
What's the formula?
A equals 5 squared.
Good. What's the radius? Yes, ma'am. Good job. All right, write it out. Yes, sir.
I fixed it to the facet, but it just keeps on going.
All right, what's the answer? Should work fine. Okay, I'm happy with that. Does everybody else please double check that now? Everybody's good?
Yeah.
All right, so now let's take a look at number 4. Harrison, give me the formula for number 4 again.
Okay, area equals 5 times 5 squared.
Good.
So, that is 5 times 1.35.
Why is that?
Because you gotta cut the decimal.
What is this?
Oh,
It's already the radius.
so 5 times 3.6 squared.
Yep. Everybody, don't wait for the answer.
40.7.
0.7 what?
72.
And then we'll go with kilometers squared. Are we okay with that? What? Yeah, number 5. Go. Tell me the formula.
Okay, so it's A equals 5 R3. The radius would have to be 5 times 2.
Okay.
A equals 5.25.
What's the answer?
I got 86.
And then in this case, we're using feet. Is that right?
No, sorry.
Oh, yeah, I was looking at the wrong one. Thank you. Everybody okay with that? Okay, now, everybody agrees that's not too hard. All right, so now the important part. Questions 6 and 7. All right, questions 6 and 7. Those are the thinking questions. Those are the ones that you want to be good at. All right, that's kind of like the ERB stuff. All right, number 6 is supercritical. All right, James, read.
A motion detector at the corner of a building can detect motion outside within a radius of 20 feet as shown. Within what area can it detect motion? Not a condition.
So tell me what you're thinking to do here. You see what? Can you see the picture? All right, so if I'm trying to detect the area that can be detected, how would I figure that out?
Figure out the area of the circle and then take 1/4 of it.
Yeah, you can take 1/4. So if I take 1/4 of it, then what do I have to do? So let's just say, for example, let's say the area of the circle was 100. What's a fourth of 100? So then this over here would be 25, right? So how much area would there be? No. How much area would there be that is detected by, what would it be? Oh, no, you're right though, but I'm going to ask you that in a second. What?
75%.
Well, not 75%. There would be 75 square feet left. You agree with me? Because I cannot, I can't use the motion detector on that part, right? So again, this is why I think this is important. So I want everybody to stop and listen for a second, just to make sure you're understanding me. All right? Because I know you probably would have got the right answer, but I'm trying to make you say it correctly. So you put a camera right here, guys, in your corner, right? And you're detecting what's on the outside, right? So your camera goes this direction, and then it comes back this direction, so it can see that much, because it can't see what? Inside the house if you put the camera on the outside of the house. Do you understand that now? Right? So the question we were saying is, this right here, this part would be the entire circle. Everybody see that? That would be the entire circle. But is that what they're asking about? No, they're not asking about the entire circle. They're asking about what fractional part of the circle, Chloe? They're asking for 3/4. So what he did was correct. You could take what? You could find the area of the circle, then take 1/4 of it, and then subtract it. Or, this is what I want everybody to understand, so look up, make sure you're hearing me. The area that is in question is area equals pi r squared times what? Fraction. Times 3/4. You are brilliant. Now, again, you're supposed to tell me right now if you don't understand why it's 3/4.
I understand it. Could you also do it like
Yes, but we're going to do it the fastest way. All right, I want you to understand that this right here that I'm highlighting, paying attention, is what fraction of the whole circle? 3/4. So it'd be easier just to take the area of the circle and multiply it by 3/4. If you wanted to multiply by 1/4, then you'd have to do what? Subtract it. All right? Yes, ma'am.
Why do you multiply?
By what?
Why do you multiply it to 4?
Well, that's because I know that this represents, and you have to tell me now, kiddo. Do you understand that that represents 3/4 of the circle?
Yeah.
In math, what does of mean? There you go, 3/4 of the circle. Do you agree with me now, right? 3/4. I'm trying to find 3/4 of the circle. All right, so now everybody's writing that formula. So A equals pi. What's the radius again? I already forgot. 20 squared times 3/4. So here we go. What was it?
I figured it out.
Yep, that's what I'm saying. Hurry up.
When you're multiplying it out, would you have to make the fraction a decimal?
I don't care. I don't care. The calculator will do everything. Depends on how you like to do it. What?
I got the answer.
Well, go ahead.
942.48 feet squared.
Yes. All right, somebody double check that, because you know,
Yes.
all right, you know how he is. Gets it once every 10 questions. All right. 942.48 square feet. What?
Why doesn't the square go at the end of the column? Because like if you have to add
This, listen to me now. I understand your question. This represents the area of the circle. Correct? I only want what part of the circle?
3/4.
That's right. So I'm taking 3/4 of that amount. So you do pi r squared, then times 3/4. All right, Lucas, I want you on the next problem. Read it carefully for me, please, and then try to tell me something. Hold up a second. Let me pull it up here. Go.
May is making donuts.
Pay attention. Hold up. Go again.
May is making donuts. First, she cuts out a circle of dough with a diameter of 8 centimeters. Then she puts a hole in the middle with a diameter of 3 centimeters. What is the area of the top of the donut? Round to the
I don't understand this. If you had to cut something out of a donut, why would you cut it out? Why not just give me the whole donut? Why are you taking a piece out?
And I agree. Can we just not do that question?
Yeah, I don't understand that. Anybody understand why the donut has a hole in it?
Yes.
Why don't you do that?
So you can make that out the
I have
donut.
no
Without
idea.
the hole in the donut, there wouldn't be donut holes.
Ah, thank you. I knew there was a reason. All right, but if it's a hole, if you're buying a donut hole, what does a hole represent?
3/4.
A hole is nothing.
No, it's a hole.
You're buying nothing.
No, a different kind of hole.
Wait.
All right, so here we go. Now,
Do that question.
watch this. I'm going to create a donut. You are too. All right, there's our donut. All right, now what is, Lucas, what is my radius? 4. So now we're going to draw a radius that is 4. 4 centimeters. Now you're taking and creating a hole. And this hole, all right, that radius will be how much, Lucas?
1.5 centimeters.
Yes, 1.5 centimeters. All right. So if I draw from here to here,
My hole is not big enough.
I believe it. So this right here now is 1.5. All right. Now the question I'm trying to ask you is, they are trying to find the area of the donut. So I'm trying to convince you that that is what I'm trying to find. So I'm going to ask Lucas, how am I going to find that?
Well, now the radius of the top of the donut is 2.5. Or the edge of the top of the donut going to the hole of the donut is 2.5 centimeters.
Do I really care? I'm asking Lucas for some help. I'm trying to find out the yellow region. How do I find the yellow region, Lucas? Jackson, you think you know?
Yes. You calculate the area of the whole donut, including the hole. And then you calculate the area of just the hole. And then you subtract the whole area minus the...
Very, very nice. That is called an annulus. All right, that shape is called an annulus. All right, so please listen to what I'm saying. I'm going to show you the formula. He's 100% correct. So I'm going to, and then you tell me what I'm doing. Area equals pi capital R squared minus pi lowercase r squared. Now, why is it upper and lower? Tell me.
It's the upper, but then it's the big version of the small.
That is 100% correct. 100% correct. That's all there is to it. All right? Shaded region is always the area of the big minus the area of the what? Small. All right? Very good. So now, what was the big radius again? What's the big radius, please? 4 squared. What's the small radius? 1.5 squared. Now everybody type that in on the calculator, please. The calculator will do all the operation for you. Just type it straight in. Type it straight in. Harrison, did you come up with something? 43.20 centimeters squared, but we got to have confirmation. Someone else has to do it also. Is that correct? Come on, don't take his word for it, please.
That's right.
It is.
Is that right? Okay, thank you. 43.20 centimeters squared. Tell me. No, I already said that. Type it straight in. Go. Type in. Let's go. Chop, chop. Look on your calculator. Pi times 4 squared minus pi times 1.5 squared. Boom, that's your answer. No, type it in.
PEMDAS.
The calculator understands PEMDAS. That's what I just said. Your calculator understands PEMDAS. All right? That's why it's called a scientific calculator. All right? If you have a 4-function calculator, it does not understand PEMDAS. All right? It'll give you the wrong answers unless you type it in properly yourself. When you have these scientific calculators, they understand order of operation. All right? Moving forward. What?
I don't understand why we had to minus 2.
There's a hole.
I know.
So we had to subtract out the hole. Look, right here. So right now I'm going to show you something. All right? So here, right? There's the whole thing. Would you agree?
Yeah.
Right? So that is pi times 4 squared. Agreed? All right, now someone dumb came along and said, I'm going to make a donut by cutting out the hole in the middle. Why would he do that? I have no idea. Because now I have less donut to consume. So I subtracted out that circle. The big circle minus the small circle. You're welcome.
I don't understand that.
If I ate that in the middle, would I be adding it or subtracting it? Shh. Of course, you're subtracting.
Okay, wait, no. I'm confused. I know what the big one is, but the little...
There's nothing to be confused about. Truthfully, seriously, come on, look at that again. The whole thing, right? Do you understand now?
Yeah, but...
All right.
Wait,
No buts. Do you understand?
I don't understand what the...
Look right here. This right here, pay attention, is the area of the whole circle.
Okay.
Right? Then I came along and tried to be funny, and I said, okay, I'm going to create something really not good for you. I'm going to cut out part of the whole. All right? I'm subtracting out that amount. All right? Now, next part is I want everybody to go down to now and really pay attention, please. We are going to look at question number 21. Now, again, this is what I would consider to be a hard ERB question. All right? So anybody read number 21? And actually, I'm going to grab it. All right, here we go. Go, read. Kate Mitchell.
The trunk of the general Sherman tree
Sequoia.
Sequoia National Park has a circumference of 102.6 feet. If the tree were cut down at the base, what would the area be?
Okay, so if you know what this is, it's a huge tree, and it actually exists. There is a tree that is 102.6 feet around. That's how big it is. It's amazing. Huge. Super big. All right? So now what I'm going to do is, this is why I'm telling you really, really important, so I need everybody to pay attention here. Because we got to use everything, that all of our skills from yesterday and today. So, when you measure around, it's called the what?
Circumference.
It's called the circumference. So, circumference of that is 102.6 feet. And what that means, again, just to review from yesterday, if I walked around that tree, if I go around one complete time, I will have walked what? 102.6 feet. Everybody agree with that? All right? Now, the question remains, though, is we're trying to find what the area is. All right? So now you should be able to tell me what the formula is for area of a circle. What's the formula for area of a circle again? I'm listening.
A equals pi r squared.
Right, so the only way I can find the area of that cross section or the area of that is to be able to find the radius. I have to know the radius. Do I know the radius? No, I don't have the radius. So the question is, how do I figure out what the radius is? Yes, tell me. Mr. Horan, no. Ben, let's go. What would I do?
You would divide it by pi.
You are awesome. All right. So the first thing I want everybody to do is write down on their paper, circumference is pi times the diameter. That's brilliant. And right now, the circumference width was 102.6 is equal to pi d. So now we have to figure out what the diameter is by dividing by pi. That's excellent. I'm dividing by pi, dividing by pi. So the diameter of that circle is, Ben, what? I'm asking for the diameter of that circle.
32.66.
32.66 feet. All right, but I'm asking for the area. So what do I have to do?
Divide it by 2.
Yes, you do. Divide it by 2. So R is equal to
16.33.
exactly 16.33 feet. Now, how do I find the area?
Oh.
Finish it off.
Times pi squared.
So, what's the radius?
16.33.
Right, so now you just got to say it correctly. What goes first in your calculator?
Pi times.
There you go. So the area of that cross section would be
837.777 feet
square
square.
feet. Very, very, very good. All right, that's very hard. All right, very, very, very hard. All right, hopefully you said, well, I don't think that was that hard. Then that's great. All right, it's really not too bad. Again, to be able to go from the circumference to the area is kind of tricky. All right, you got to use some algebra. You have to know what's going on. All right, so I'm pretty happy with that. Now, the next thing is I'm going to grab number 24, and I'm going to ask for help on this one too. Come on. All right, so now for question number 24. The first thing I want to do is I'm going to take a walk around. All right, so here we go. I'm going to walk around, and that's going to be the distance around. All right, that's what we're trying to find, the distance around. So tell me now, the first thing on your paper is D equals. All right, so when I walk this, you have to tell me what I'm walking. What am I walking?
The diameter or the radius?
The diameter. But I'm not asking you that right now. I'm asking you, what am I walking right here?
This
The whole circumference?
no, half of it.
You're walking half the circumference. Now, come on, guys, pay attention. Like I said, these are the ERBs. This is really going to help you, I think. All right? So she just said I'm going to walk half the circumference, which is perfect. Then I'm going to finish it up by walking, what is that called? What did I just walk? Yes, plus the diameter. That is the formula for the distance around that shape. Does everybody agree with that? Half the circumference plus the diameter. All right? So now, the distance around that shape is 1/2. How do I find the circumference? What's the formula?
C equals
Pi d plus d. That's the equation I want written down. That's the equation I want written down. Make sure you're writing out these equations like I said. All right? Now, tell me what the diameter is.
the diameter is 8.
Right, so d equals 1/2 pi times 8 plus 8. Now plug that into your calculator. It will do the order of operation for you. So the distance around, I'm waiting up here. Approximately 20.57 millimeters. Anybody else get that? Is that about right? Anybody else get that? 20 point?
I got 20.67.
Okay, so remember, I'm not worried about the last little bit. What?
I got 7.
Okay, so then you're wrong. So type it again. I know it's hard, like me. 1/2 times pi times 8 plus 8. All right, double check that. All right, what? You did the problem for me.
I know. I'm just confused why you would for like the circumference where you do pi d plus d instead of pi d divided by 2.
That's what this is. Pi d divided by 2, kiddo. 1/2 is the same as divided by 2.
Oh, so what's the plus d at the end?
Did you follow your walking path? What is this called? No. Half the circumference. Then I continue walking this way. I walk the diameter.
Oh, okay.
Right? Now, heads up for a second. I'm going to ask you one more question, then I'm going to let you on your own. All right? I want someone... Oh, I forgot to do area. Sorry about that before I go into my other one. Somebody tell me how to find the area of that. What would it be? What's the formula?
Area A equals pi over 2. Or 2.
Anybody else? What do you think? What's the area of this shape right here? What I'm at?
So it would be A equals pi and then 4
No, I want to know the formula. He's not correct. It's hard to believe.
for divided by 2.
Come on, that's where you're supposed to jump in before he does. It's half of a circle. It's half a circle, correct?
Yeah.
So it wouldn't be pi r squared. Now, I wish you would say 1/2 pi r squared, but is that the same as pi r squared divided by 2? Yes, that is the same. That's the same. What? Quick. So everybody's just...
I know what I'm saying. Do you do something with the half and the pi? Do you have to like type them? Or?
Yes.
Oh,
That's what we've been doing.
cool.
1/2 pi. What's the radius, guys?
4.
4 squared. And that was roughly what?
25.13.
And then we would say millimeters squared. We would say millimeters squared. All right, now the end of the story here real quick. Come on, come on. All right, end of the story.
No.
It's all right. Number 26. If I said, what's the distance around? What's the distance around? Someone speak up. Harrison, what? Nope, I'm not asking that. I'm asking you this, Harrison. Come on, Harrison. Get in the game now. Here I am. I'm going to take a walk around this here, here, here. So I'm asking from here to here, what is that? Shh. That's the circumference. That's not a circumference. Come on now. What part of the circumference is it?
1/4.
There you go, man. Come on, you know that. Correct? Circumference is all the way around. We only went what?
1/4.
There you go, buddy. All right, so here we go. So we're going to write distance is equal to 1/4 the circumference. Now, Harrison, I'm going to continue walking. What did I just walk? What did I just walk? Yeah, so you could say plus D because you walked how many radii? 2. So you could say, I wish you would say plus 2r because that shows me that you broke it down into radius and radius, correct? But it's the same as the what? Diameter. Okay? Now, area equals. Yes.
The area of that is like the
Yeah.
area.
No. The area of the shape we're talking about.
Okay. Like the whole area?
Yeah.
Oh my gosh, no.
Yes, thank you.
That
Go.
one little
Shh.
area.
Here we go. Come on.
So, area equals pi, right?
Yes.
Okay. And then times 20
No, we're not doing numbers.
Oh wait,
R.
R squared.
R squared. So we're doing the whole area of the whole circle. Is that what you're telling me? Shh, no one else tell her. Shh, are we doing the whole circle?
No. We're just
No,
doing that part.
what part of it?
One part of it.
Yay.
Times a 1/4.
Wow, brilliant. Thank you. There you go, girl. That's it. That's how simple it is. Come on, it's simple. Simple, simple. You got to pay attention. All right, you got to pay attention. What?
So for the distance, what is the 2? Like the C plus 2R?
2 radii. Are you not watching me walk? Here I am. Let's go in slow motion for you. No, I'm going to walk in slow motion for you. Here to here is a what? And from here to here,
Radius.
2 radii. Thank you.
Okay.
Wow. My great pictures, and you're saying you're not seeing them. All right. Now, listen. No excuses. All right. I want the ERB. Those are the important parts. All right. The other stuff left over was the easy stuff. All right. 8, 9, 10, 11, 12, 13. That's easy. Just plug the numbers in. The ones that I really want you to make sure you're doing are the word problems. Try them. All right. I posted the solution. If you're having trouble seeing it, draw a picture. Then look at the solutions. All right. Get busy. We still have a few minutes. All right. Get busy, get busy, get busy. Chop, chop.
This is